start with optimization. This is applications of the previous concepts on maximum and minimum values, or maxima minima. And usually optimization can be found in different subjects of applications. So mainly in engineering, we basically look for the maximum amount of material that can be used on a certain volume or area, or can be in architecture as well, in maximizing or minimizing, pretty much same similar applications on engineering. In economics, we either maximize the profit or minimize the cost of a certain product. And also in physics, the applications vary, but mainly it focuses on the minimum and maximum value, which we will be applying here. In solving optimization problems, you follow the steps. First is very important. We read the problem. We want to know what we would like to minimize or maximize. And then step number 2, we define the variables. So whatever is known or unknown, we list them down. And then step number 3, we formulate the equations. So we come up with constraint equations, and then combine them, or manipulate these equations to come up with their optimization equation. Usually this single equation combines all of the variables, and then we have isolated the variable that will be maximized or minimized, and then we differentiate. After differentiating, we confirm the result. We use the first or second derivative test to verify, so we can identify the nature of the critical point, if it's a maximum or minimum, or if that maximum or minimum is really a minimum or maximum. And let's try with some examples. Start with the first one. The question reads, what positive number added to its reciprocal gives the minimum sum? So let's take note of the keyword minimum sum. So we're looking for a minimized equation, or using a minimum, or we're looking for the minimum point of a certain function, basically. So let's have S as our sum. Okay, or the minimum sum, let's say. Okay, and then we'll have the positive number x, and then 1 over x is the reciprocal of the positive number. Okay, so our constraints, our equations, I think it would be the same equation that we will be minimizing. So the sum of the positive number and the reciprocal, which gives us the minimum sum. So this will be our equation. Okay, and then we can rewrite this, diba, since this is a reciprocal, as x plus x raised to negative 1. And then we can derive, no? So we can get the derivative of s with respect to x. And then same thing that we will be doing here, x plus x raised to negative 1, we get the derivative with respect to x. So for s to be a minimum, we need to have ds over dx as equal to 0. So we will equate it to 0, but we'll derive this first. Okay, so when we combine this will be 0 is equal to, then the derivative of x plus x raised to 1. So the derivative of x is 1, and then the derivative of x raised to negative 1. So power rule, negative 1, then x raised to negative 1 minus 1. So that gives us minus x raised to negative 2. Negative 1 minus 1 is negative 2. So when we rewrite the equation, so this will be 0 is equal to 1 minus 1 over x squared. We transpose 1 over x squared. Alright, and then we multiply x squared on both sides, which will give us on the left hand side will be left with 1, x squared will cancel out, then you have x squared. When you get the square root of both sides, you'll get x as positive and negative 1. Okay, so we have two values. Let's write down the two values. So x1 is positive 1, x2 is negative 1. However, we remember we are looking for x as our positive number here, di ba? So we reject the negative number and then we keep x1 as the answer. Okay, so to verify the critical value, because basically this is the critical value, x equal to 1. To verify if it's a minimum, or if this critical value will give us a minimum value of s, so we use the second derivative test. So we derive again the equation, but we have 0 is equal to 1 minus 1 over x squared, which is also 0 is equal to 1 minus x squared. We just get the common denominator. Okay, and then when we derive again, and then we can derive it easily with this equation pala. This is the original equation. This is the derived equation. You will just derive it again. Okay. So when we get the second derivative, you'll end up with 0 again, and then this will be 0 minus, remember this is 1 minus 1 over 1 minus x raised to negative 2. So when you derive the constant, it's 0, and then you got negative 2 x raised to negative 2 minus 1. So that's 0 plus 2 x raised to negative 3, or 2 over x cubed. Okay, so remember, using your second derivative test, you can substitute the value of your x. Okay, you substitute the value of x, and then f double prime of x1. So that will be 2 over 1 cube. Okay, so this will give you a value of 2. And remember, if your value of the second derivative is greater than 0, it's a local minimum. Okay, so therefore, at x is equal to 1, it's a local minimum. This will be our answer.